We're going to kind of switch gears a little bit and start talking about carcass and iodine value and near-infrared technology and hopefully shed a little bit of light on what's going on with the packers, because we work very closely with several of the packers in Iowa and Minnesota, and they're also scrambling and having issues with soft fat. And so you're not alone as far as doing diets and calculating diets and getting those pigs to market. The packers are also wondering what's coming at us as far as and it's just not the bellies. There's some other things that we'll talk about. Okay, and I don't have any of my students here, so I may have to borrow some of Dr. Patience. Okay. All right, let's see if we can get this thing to go. All right, so we're going to switch gears and talk a little bit about quality. We are at the Sensory Center at Iowa State University. We're very concerned about quality of pork, quality of bacon, quality of hams, and we go to great lengths in the evaluation of these various factors. You can see here we do aroma evaluation. Aroma is becoming more and more important, especially as we increase the unsaturated fatty acids in the diet. As we increase those unsaturated fatty acids, that diet may be more prone to oxidation. It may be more prone to rancidity. And so we have to be very careful about how that bratwurst, basically, or dried cured ham, what type of aroma characteristics are coming from that. We're also concerned about flavor and texture. This is a sample of pork, and it's just not distiller's grains. We're seeing if you start feeding some very strange things, pigs, as you know, pigs are notorious that whatever they eat, they're probably going to deposit it somewhere in their bodies. And so if you're feeding something that is extremely flavorful and have a lot of flavorants, it can be transferred directly into the meat. I know we received some samples of pork from the East Coast where they were feeding clam byproducts. It was the worst smelling stuff we'd ever had in the lab. We were also working with a group that was feeding garlic. You didn't need to add any garlic to that pork. It'd drive you out of the lab. So some of those very powerful flavorants in very small amounts can cause problems with acceptance farther down the road. So we're very, very careful. We have sensory booths to where we train individuals to evaluate products very, very carefully, to look at differences in diet, genetics, seasons, those types of things. Okay? And as we move forward, diet and rations are just one of these things up there. We're actually involved with several producers, several packers to where we're looking at everything. Genetics, rations, management styles, delivery, how far away from the plant, all affects that ultimate pork quality. We think of it as a package. Packers have done a very good job as far as installing things like CO2 stunning, also deep chills to get the temperature of the carcass down to control some of that quality. And so all the way through the system, we're looking at ways to maximize the quality, because I think if we're going to go, and you guys are going to go to all that effort to grow this pig, we should produce the highest quality pork out of it possible. And whether you buy it at Hy-Vee or whether you buy it in downtown Tokyo, we really believe that we have an ethical mission to produce extremely high quality pork. Those are some of the factors we can control. What can't we control? Anybody? What can't we control? Weather. Very good. We can't control weather and some of that biological variation even that John was talking about. And weather plays a big role. We'll see seasonal effects in pH specifically, and we're probably going to be going, and it depends on temperature and time, but we're probably going to go into a time now. Again, usually in the spring is when we start seeing complaints about color problems, pH issues, things like that. And we're still trying to figure out why. And we're trying to figure out what causes some of those things when that seasonal difference in that pig changes. But today we're here to talk about fat. And you think it was a new issue? Well, I found this paper in the Journal of Biological Chemistry in 1926. We always think that we're inventing new stuff and that we're gaining new knowledge. But in 1926, these folks in the Journal of Biological Chemistry said the influence of character of ration upon the composition of body fat in pigs. So 85 years ago, we already knew that if you feed different things to pigs, in this case they were feeding peanut oil, corn oil, soybean oil, they were finding softer fats. So it's nothing new. And in fact, you could almost transpose some of these statements that they made in their paper into research that we're doing today. Rations low in fat produce body fats that were unsaturated, very, very firm. Unsaturated oils produce fats with characteristic of ingested fat. Basically, there's evidence that the animal body tends to deposit ingested fat in preference to synthesizing new fat. And even back in 1926, they were using the iodine value. And they recognized the iodine value was important. Of course, things have changed a little bit. Oil was $1.88 a barrel, and they were slaughtering those pigs at 190 pounds. So things changed considerably. And so we want to keep in mind, though, that we have known for a very, very long time that dietary factors really affect the carcass quality. Okay? Well, as John said, we see all of these challenges with ration management. We see distillers' grains, high oil distillers, low oil distillers. I talked to the folks at the biorenewables new building at Iowa State, and they say, we're going to try to take everything out of that distillers. There's value there. Why do we want to feed it to a pig? We want to take the oil out and send it to biodiesel. We want to break the starch or the fiber down and make more ethanol out of it. And I said, well, what are you going to give us for pig food? He said, we'll give you a pile of ash. We'll just give you some dust. And I said, that's not the right answer. We have to be aware of what we're going to be feeding these pigs in the future. But we have AV blends, bakery meal, glycerol. We'll talk a little bit about pet food, and then all those future corn byproducts that we haven't even seen yet. Okay? So everyone's seen distillers. I've got a sample of it here. If you haven't seen distillers, it's you have to be very cognizant of the quality of distillers, and they're doing a much better job now in drying it down. And you can open this and smell it. It's one of the issues with distillers that I find that oil in distillers, if you keep it around for a while, it may go rancid. Okay? We also say things like restaurant grease. All of those Burger Kings and McDonald's out there, when they're done with their frying oils, they have companies that come around and actually recycle that material and turn it into AV blends. So it's a very good source of polyunsaturated fatty acids for feeding, for energy, right? But again, you can have different levels of quality. So this is very high quality, and this is pretty poor quality as far as restaurant grease. So just a few things that we see. I always find it interesting about Twinkies. Is anybody feeding bakery meal? Don't be shy. Come on. Is anybody feeding bakery meal? This is bakery meal. Okay? So anything that doesn't make code or is outdated or, doesn't get into the box right or is falls on the floor at major bakeries, they turn it into something called bakery meal. And so it can be anything from any wheat. And this plant up in, this was actually in Minnesota, they try to get the plastic out, but these pigs are probably eating these boxes, right? So they leave some of the box material in and break it down, and they turn this into bakery meal. And that's the sample that I have there. And what we're finding as an issue with bakery meal is it could change from week to week depending on the products that are going in. If you're near a huge plant, you probably have a pretty good idea, of the composition of the bakery meal from week to week. But, depending on what they collect that week, there could be some variation. And there's some, and I'll just show you the composition. The company in Rosemont is Endres Processing, and they dry it down to 10% moisture. And this is a plant in Minnesota, and their plant in Battle Creek, Michigan. You look at proteins, about 12, fat is 9. Again, I don't know what that fat is, whether it's saturated or unsaturated. It's a good question to ask. Sugars are 12% in this case, and starch is 20. And look at the profile. What do they make in Battle Creek? Kellogg's. They make cereal. So the composition of that bakery meal is going to be dependent on a lot more sugar and a lot more starch, a little less fat because they're making cereal or collecting cereal. Now, just some very, very preliminary things with bakery meal. it doesn't bother me, but it makes me a little bit concerned about feeding high levels of sugar to pigs, because there are some studies out there that if you do feed high levels of sugar to pigs right before you slaughter them, you get a rapid pH decline. And you get, because there's a lot of sugar there and available for lactic acid buildup. And there could be some issues with color and pH. So that's totally different than the fat issue that we're looking at. And we've got a study going on now looking at feeding different levels of bakery on loin quality and not so much on fat quality. Okay. Also, Iowa's the #1 egg producer, right? We've got a bajillion chickens in Iowa. And we're the #1 egg producer. I think we have like 50 million chickens in Iowa or something. That might not be totally correct, but there's a lot of chickens in Iowa. And so when they're done laying eggs, what do we do with them? Campbell's Soup doesn't want them anymore. You know? So they grind them up, they heat them, and we turn it into spent hen meal. And that's available for pig food also. But it's a little bit too expensive to feed to pigs. And so what this is going to is pet food. And that's not a big concern for us in the pork industry, but I do have 2 producers that I work with that are feeding pet food meal. So they're collecting all of the out-of-date dog food, cat food, whatever, from various plants, and then they're feeding it to their pigs. And one gentleman in Kentucky was actually feeding 40% pet food meal. And we had very limited information about what was in that. And so he had very soft bellies. And so we're finding the iodine value of that material was quite high. So that's just a few things that we're seeing out there. But as Dr. Patience alluded to, we have to be more concerned, not just the composition of the ingredient. We have to be we have to worry about the fat content, the corn oil content, and then those unsaturated fatty acids. And even to the point of how much linoleic acid is in that ingredient. Because those are all things that are going to affect the iodine value that the packer is going to be looking at. Okay? So everybody, little chemistry here that knows your fatty acids. This is stearic acid, so this would be a complete saturated fat. So, and I show you this for a couple of reasons, because 1, to show you what the difference between saturated and unsaturated is, but 2, it'll give you the basis of what the iodine value is. And we want to make sure everyone understands what the iodine value is and what it's measuring. So this would be linoleic acid. It has 2 double bonds right here. And so when we start feeding those fats with more double bonds, it becomes more oil, and that pig's going to deposit it in its tissue. Okay? And that's where we get issues with soft bellies. Just as a side note, a little chemistry here. Has everybody heard of omega-3 fatty acids? Fish oils, those types of things. If this first double bond would be right here, that would be an omega-3. That's totally what it is, just a difference in structure. So this is the alpha end of the carbon, or the acid. This is the omega. So if the first double bond is right here, that's an omega-3. This is an omega-6, and our bodies metabolize those totally differently. Okay? All right. You've seen this slide. This is from Trey's work, and I think it shows, and I use this slide just as an example. This is what Dr. Patience had. I took out some of the other material, but as you start feeding more polyunsaturates down here with corn oil, 3 or 6%, you're going to boost those iodine values up over 72, 73, 74, up into the 80s. And when we start getting into the 80, 85 iodine values, we see some major issues in the plants, especially with soft bellies, and I'll show you why here in a second. What I also thought very interesting with Trey's work was by site. You have some packers that are sampling the jowl. You have some packers that are sampling back fat. You have some packers that are sampling the belly. And are they all the same, or are they different? And the answer is maybe. Or they could be, because as you can see with Trey's work, the yellow is belly fat, the red is back fat, and the jowl is the brown. And so generally we say if you're sampling in the jowl, on average you're going to be about 2 points, maybe 1.5 point higher than if they're sampling in the belly. A little bit different composition of fat. Is that right, Trey? Okay, good. So that's why I show you this, because one thing, if your packer is sampling, a good question to ask is where they're sampling, how they're doing the iodine value, and we're going to go through those calculations here in a second, and how they're arriving at those various levels of, kind of that 74 or 72 that we hear about. Okay? There are some established guidelines. Again, this is nothing new. Denmark has established an iodine value of 70, and that's been around for a long time, as far as the Danish Meat Research Institute, and that's pretty strict. That's probably feeding not very much unsaturated fat, or they take it all the way down to the linoleic acid content of 1.6%. The United States recommendations are not clearly defined. Boyd has, in 1997 said 74, and that's where we're getting that 74 value. But again, there's no clear-cut recommendation that we're seeing from all the different packers. And I know National Pork Board is working on maybe some recommendations that will give us some more clear-cut guidelines. Okay? Well, let's talk about soft fat issues. And everybody's heard about the bellies. And it's the most, it's probably 30-40% fat. So in these higher fat products, that's where we're going to start seeing issues with softness. We're going to start seeing issues with processing those various bellies. And the first thing, that if you get a soft belly, let's say an iodine value in a belly of 72 versus 82, 10 points, or even 85. Thinness on the 85, that belly at 85 is probably going to be a little more thinner. And so what happens when this belly is moving down the line, the first thing that they do is they take the spare ribs off. The spare ribs lay right here in that belly, and they have this U-shaped knife, and they come in and they dip into the top of the spare rib and they pull it out. It cuts it underneath, the spare rib goes off, and the belly goes on. Well, if that belly is very, very soft, it kind of bunches up like an accordion. They can't pull that rib off. They have to go too deep, and they score the belly. So if they score the belly, they go into it too far, or they cut it, Oscar Mayer's not going to accept that belly. They're going to reject it because it's not a number one belly. Because it's damaged, they can't make bacon out of it. Okay? And so that's one of the biggest things that we see is those spare ribs are very hard to get off on softer bellies. Firmer fat, nice, firm, hard, white fat, those spare ribs just pop right off. Okay? Also, skinning becomes more difficult. Just about, I don't know the percentage, but most of the major plants, like in Marshalltown, Iowa over here, they're skinning 100% of their bellies. They're all going out as skinless. And if you have a soft, ragged belly, it's very difficult to get the skin off. And you have to spend additional time then skin patching that belly of taking all that residual skin off. And so it's another added cost to the packer if they can get the skin off. Sometimes they score it on the other side too, and they mutilate it. Okay? If you have a soft belly, it leads to increase in downgraded product. So it goes from a number one product to a number two product. And you might not think that's such a bad deal, but basically those top quality bellies are reduced to trim value. And that is a big deal. Because you're looking at a top quality belly, if you have to just cut it up and put it into trim that goes into 50/50s, which would be for sausage or hot dog manufacturer, you take about a $25 head loss on that carcass. And how do you figure that? Does anybody have a calculator? We're going to do a little math here. Does anybody have a calculator on your phone or? Okay. You have one? What's the belly prices, Ryan? Let's say high, top quality Oscar Mayer, let's say $1.20. And let's say that trim price, 50/50, I think yesterday was running at about 38 cents. So if you take $1.20 minus 38, what do you get? 82-cent loss on that belly. And most bellies on the average now are running about 15 pounds a piece. So we've got 30 pounds of belly per pig. 30 times 82 is about 25. Almost 25. And if you're killing, like in Marshalltown, Ryan, how many pigs do you kill a year? 5 million pigs a year. You can't afford to take too many losses on $25 a head, especially if you pay top value for that. So that's why we're seeing, this is even before it gets to the bacon manufacturer. These don't even get out of the plant They have combos and combos of these number 2 bellies that they're just slashing them every day, turning them into 50/50s at a great value loss. There's other issues also. A lot of major bacon manufacturers have specific dimensions that they require on their product. Let's say you have a top quality Oscar Mayer black label bacon, and they're telling you that bacon cannot be over 11 inches wide. All right? So in the plant, you cut it at 11 inches wide. You throw it in the bottom of a combo, and you throw another 120 bellies on top of that belly. If that belly's soft, when it gets to Oscar Mayer, it ain't going to be 11 inches anymore. That's pretty much common sense. We've seen some that are going to be 15 inches. Oscar Mayer says, this is out of spec. We're going to send them back. Or we're going to have to retrim them, and then we're going to take a credit on you guys. So that's where we're seeing issues. And so now in the plants, what they do is they're actually trimming those bellies, and maybe it's 13 inches or 11 or whatever. They're having to trim them 2 inches narrower to hit that 11 or 13 inch spec, because it's going to spread out before it gets there. That's why soft bellies are becoming such an issue, okay? As far as dimensional. And then, basically, we have to have increased manipulation when we produce bacon. Most bacon manufacturers now are cooling the products down more. In fact, some are actually freezing them so they can slice them because they're too soft to slice. And when they go through these very, very high-speed slicers, slice yield is very, very important. And if their slicing yield goes from 93% down to 90%, that becomes a very big issue to them. So it's all the way through the system that the soft bellies can actually cause problems. Not even to say that in some food service type bacons that are not vacuum packaged, we can actually see increase in rancidity because of that unsaturated fatty acid profile. So we could have some flavor changes all the way down the system, right? Bellies aren't alone. We also see issues with hams. You can see in this bottom ham, very, very white fat, very firm, very nice texture, to where we're seeing some of this softer polyunsaturated material here, a little softer fat. This ham is going to be much more difficult to skin. Again, there's a tremendous leanness difference here also. This ham is going to be much more difficult to skin, and you may score it versus this ham that has nice white, firm fat. And so we see it on the fresh side, but more importantly, with hams, we see it on the processed side. And the hams that we've been working with and having the most trouble with are the dry cure hams, which are very similar to the Parma hams in Italy. And that's why Parma down here specifies we will not accept any pigs with an iodine value less than 70, or greater than 70, greater than 70. Because they know that that ham is not going to dry down as well. That fat's going to be soft, it's going to be oily, and they're going to have problems processing it. And we're seeing some of that in this fat has to be very firm and very white. Okay? Because we don't want an oily texture, because basically you buy these hams in. There's a big company in St. Louis called Volpe that we're working with, that we're actually looking at different iodine values going into that plant to guarantee they have top quality hams, because it's kind of a crapshoot, folks, because if you put all these hams away, let's say you're a ham manufacturer and you have these hams and you put them away today, you don't open them or slice them until September. What if they're all crap? You're not going to say, you're not going to call Tyson and say, I've got this ham. Do you know what producer it came from? No. We have to guarantee that that ham is good quality going in. And that's the issue that we deal with when some of these, in fact, the Parma hams are 12 months old. They cannot be sliced until a year old. And so there's a lot of value locked up in these hams. And that's where we're seeing issues. Okay, we'll move on. We're also seeing issues with soft shoulders and soft blade ends of the loin. And you can see the separation that we get in the fat right here coming off of the loin tissue. And if that separates, the retailer, especially in the blade end of the loin and in a butt, which is up in the shoulder, they're going to be much more difficult to slice. You can't put these on the high-speed slicers because there's no integrity there. It's very, very soft fat, and they start to lose slice yields. And this is especially critical in the Japanese market because the Japanese are slicing these things almost paper thin. they'll get 16, 18, 20 slices per pound. And so it's very, very thin sliced. They don't eat 1 1/4 inch Iowa pork chops with the bone in, folks. They're eating pork by the gram in Japan. And so they're much more critical on quality. And basically, the processors, when they slice these, they want to make sure that they stay together. Because if they don't stay together, the customer is going to reject it. Okay? Other things, sausage manufacture, we talked about some of these textural issues. Bratwurst is extremely critical. Some others that are high fat, some of the dry sausages. Again, if that fat is too soft, it's not going to dry down properly. It's not going to have that nice bite. And I know Johnsonville produces all of their product from sows, but that doesn't mean they're not concerned with feeding distillers and unsaturated fatty acids in those products. And then again, some of these non-vacuum packaged processed products that contain salt and light can go rancid faster. And so that's where, and it's very difficult, I know, to put a value on all this all the way through the system. You know, the bellies are easy. You sell it as a number 1, you sell it as a number 2, you lose $25. But if you've got a customer out there that's saying their fat is going rancid, 3 or 4 months from now, it's very difficult to put a value on that. And then you might even see things like choice white grease. We were in a plant the other day. This company buys a lot of choice white grease. Their soap isn't setting up. The crayons that they make out of the choice white grease have a different texture than they used to because of more polyunsaturated fatty acid in that choice white grease. So you want to think all the way back to the system, but what you're feeding today may be affecting crayons in the box. That's all the way through the system as far as what we deal with every day. Okay? All right, so how do we measure fat quality? Just quickly, I've got about 5 minutes here for a few questions. We can just take a look at it and do subjective firmness. We can pick it up. We can look at the flop as far as how, if the belly, the ends come together, it's very soft. If it's stiff, you can give it a subjective measure. A lot of folks are doing that, but the problem with that, it's temperature dependent. If those bellies are 32 degrees versus 42 degrees, they're going to be totally different. And in a plant situation, when you have 9, 10, 11 coolers that might be all running a little bit different temperatures, it's very difficult to do these subjective measures because you could have bellies coming out at different temperatures. You might not, you will have. This is the flop test, measured on skin on. The belly's draped over a rod, and then we do the angle. And I've got a picture of this. It might be easier just to show this. So this would be considered a very soft belly, okay? And so it flops over this rod, has a potential to be a number 2, to where this one is much firmer. And so you would either measure the distance between the two ends, or you would measure this angle. And again, that's temperature dependent. If that belly's 32 degrees, it's going to be stiff. If it's 42 and been fed unsaturated fatty acids, those ends can actually slap together. Okay? That's why we're interested in the iodine value, because it's not temperature dependent. It's dependent on those unsaturated fatty acids that are in that tissue. And so this is the iodine value. If you remember that fatty acid I showed you, these double bonds, what the iodine value is basically a chemical reaction to where they mix the fat with iodine. Iodine binds to those double bonds, and so the more double bonds you have, the higher the iodine value. Okay? It's not a quick measurement. You can't do it at current line speeds. And we'll talk about the iodine value here. Again, you probably have seen this, the iodine values of different fats and oils. Coconut oil probably shouldn't even be called an oil. With an 8 to 10 iodine value, it should be called like coconut sludge, I think. Beef tallow, then again, what Dr. Patience was talking about, this variation we also see in iodine value. Lard, choice white grease, somewhere between 68 and 72 now probably, because we're seeing the iodine values of the choice white grease slightly go up in the plants that are killing a lot of pigs that are being fed distillers. Corn oil, again, comes in at about 128. Soybean oil, a little bit higher. And then this is fish oil down here. Okay? And so and again, you're going to see variation, and I'll talk about variation here in a second. So there's different ways to do the iodine. Yes, I'm sorry. What's the difference between lard and choice white? Lard is actually processed. So when you go to the store and buy lard, it's what you would make pie crust out of. And that's been processed. It's been actually rearranged, so those fatty acids are a little bit different. So lard's the commercial product that you buy in the store. Choice white grease is what you see in the plant coming out as coming off the pig, rendered fat. Does that make sense? You can buy lard or choice white grease in the plant to make lard out of it. All right? So it's basically lard is the commercial product that you buy in a store. You can do a direct iodine value, fat removed from the belly. Pure fat is submitted to titration. Basically, the more double bonds, the higher the iodine value. There's labs around the country that will do this for you for $30. Takes about a week, okay? And so $30 for an iodine value. You can also do a calculated iodine value, and Trey's doing a couple thousand of those probably right now, right? Okay? And so you determine the fatty acid profile, look at those different fats, and then this is the calculation that you can do right here to calculate an iodine value. I agree with Dr. Patience and some other professors that the calculated is probably better, or to do the actual fatty acid profile, because then you know how the fatty acids are changing. Where the iodine value, you get one number. Okay? But with the fatty acid profile, you can see how your dietary ingredients are affecting the composition of that fat. Because you could have two different profiles depending on where those double bonds are, and you could have two different iodine values. So this is basically the calculation. Again, 18-1 double bond, 18-2, 18-3. You can see we put more weight on those. And this is a published iodine value calculation that's approved by the oil chemists. Right? What we're going to see in the future, though, you can't do fatty acid profiles online. You can't do any of these others. We're going to use near infrared. It's coming, folks. Basically, we're going to use near infrared. There's two different applications there. There is a laboratory application where you remove the fat from the carcass. You take it up to the lab in the plant, and there's a spectrophotometer there. You lay the slab of fat on the spectrophotometer. It's a near infrared spec. You get an iodine value in about 3 seconds. Okay? And there are several packers that are doing this out there today. And those are laboratory type measurements. They're not online. What we see coming down the line, though, speaking of online, is basically an online application of near infrared to where we're going to be probing carcasses on the slaughter floor. And basically, right where the tattoo is, where the fatometer is, where the ultrasound is, where we still have the tattoo, we'll do an iodine value right there, and you may start seeing that on your kill sheet, okay, in the future. There's a couple of different applications. One is on the slaughter floor. The other is actually on the cold side, and we've talked to some packers that may use it to sort bellies going to different suppliers or different processors. Okay? And then we've even talked with some of the belly processors, bacon manufacturers. The packers are a little nervous now because they don't want a bacon processor saying, I'm not going to buy bellies for you that are over 72 iodine value. That would be a train wreck because right now there's no rapid way of measuring those bellies to meet that spec until this near-infrared technology comes around. Okay? And so we're working in concert between those packers and processors to make sure everything is measurable so there's no big hiccups in the industry. Right? Even with iodine value, and this is a slide that I got from Jason Apple down in Arkansas, look at the variation in just belly variation as far as iodine value. 71 up here in the dorsal, down here to 67 in the ventral. So again, it's very important where you measure. You can take fat from two different locations in the belly and get two different iodine values. And so that's what we're trying, and that's why this near-infrared technology is very exciting to us in meat science, is because we'll finally have a tool that we can get a lot of data. Because right now, if you take 10 iodine values, it's $300. And so that adds up very, very quickly. So we need to be able to measure these things before we can start making recommendations. Also, whether it's lean tissue at 61, there's also a secondary lean here at 63, intermuscular fat or subcutaneous fat, may all vary in iodine value. Okay? And so that's what we need to get a handle on to get a uniform measurement and where we're going to be doing it in the plants. And just the other day I was in a plant and I always had this question in my mind, how does pig leanness, carcass leanness affect iodine value? So I did this little bitty experiment, probably, no reps, John, sorry. No, I know the diet, okay? But basically I took a load of pigs coming into a major plant. We got the percent lean off the fatometer right as the pigs were moving across, and I took 5 of the fattest pigs I could find. So I've got an average percent lean here of 51. 221, so they were pretty heavy, right? The bellies out of those pigs weighed about 18 pounds. They were 1 inch thick in the center and 1.3 on the edge. That's where we measure our thickness in the plant. And the iodine value came back at 67. All right, so remember 67 and 51. And then out of that same load, I took the 5 leanest pigs. So we were looking up here at about 60% lean, 59. Bellies were a little lighter here. Carcasses were a little lighter. Bellies were a little thinner, and the iodine value was 75. So just that fattest pigs to the leanest pigs, we saw a difference in iodine value of about 7 points. So again, I'm still kicking myself because I don't know which ones are barrows and gilts, because we also see a difference in barrows and gilts. I think it's basic, barrow and gilt differences probably. The gilt's going to metabolize its fat a little bit differently. And so we do see sex differences. And so I think there probably is a gender effect in here. Also, I think those leaner pigs are they turning their fat over faster, John? Yeah. So they're laying, they're not storing it. And so they're utilizing their fat better so it doesn't have a chance to be stored. Okay? And by the way, these diets, there was 10% distillers in these diets. Okay? All right, so just to finish up, general trends in iodine value as we talked about. Rule of thumb. In our work at Iowa State, along with the work at K-State, we see for about every % increase in distillers in the diet, your iodine value is going to go up about 0.33. So if you, again, as we talked earlier, if you're going to increase distillers by about 10%, your iodine value is going to go up 2 or 3 points. Okay? Just in general. Again, differences in belly. The jowl runs a little bit higher. This is a calculation that we've come up with, that the belly is basically, the jowl is going to run just a little bit higher. If you multiply the jowl by 0.98 or so, you'll be able to get the belly IV. Again, gilts are usually 2 to 3 points higher than barrows. And paline increases 1.5 to 2 points, again, depending on how long it's been fed and the level of feeding. We've also seen that not all pigs, and I probably should have genetics here also, may not respond to step-down rations as well. If you're feeding 30 and you go down to 0, we're still looking at that interaction, but maybe not all genetics respond the same way. Or if you go 25 to 5, which I know some producers are doing, it's not a sure bet that the pig's going to come down as rapidly as some others. And also, we have to think about moisture. You think of a belly and fat as being pure fat, but it's not. It's only 80 to 85% fat. There's 20 to 15% moisture there that's going to be, cause softer bellies also. And so that's why we see, again, some of the bacon manufacturers firming up bellies that have more water in the fat so they can slice them. And in summary, basically, and as John indicated, you must consider all fat-containing ingredients, not just distillers in your formulation. That's a no-brainer. Make sure you're aware, next time you're putting in that distillers, make sure you're aware of crayon firmness. Okay? All the way through the system, folks. Not just bellies. Think about soap, crayons. There's other people down the line that rely on that fat firmness that we're seeing issues with coming out of the plants. Basically, various packers may have different concerns. If they're a processor, if they're a bacon manufacturer, if they're a heavy export plant, they may have more or greater concerns than just a commodity type of plant. So we're seeing various levels of interest in iodine value throughout the packers. But basically, sooner or later, and we think probably within a year, we're probably going to see a rapid measurement online that's going to be near infrared that we may see some of these packers adopting in the future.